Good morning, students. Today we'll be studying about atomic structure, what is valency, and how to write the formula of chemical compounds. In order to study about the atomic structure, we need to know what are atoms. Atoms are the smallest particle of matter which may or may not be capable of independent existence. But atoms take part in a chemical reaction. To find out the structure of an atom, you will find in the center of an atom, we have a structure, we have the part which we call as nucleus. Dalton, after a lot of research, came to the conclusion that atoms cannot be further divided. They were indivisible and indestructible particles of matter. Later, scientists proved that atoms can be divided further into smaller particles called as subatomic particles. These subatomic particles were of three types, represented by the letters P, N, and E. In the center of an atom, you will find the nucleus is present. This nucleus contains two types of subatomic particles, particle P and particle N. P stands for protons, which are positively charged particles. N stands for neutrons, which are neutral particles. They do not carry a charge. Protons carry positive charge. Around the nucleus of an atom, you will find they are surrounded by shells or orbits. These are the shells or orbits. On these you will find the electrons are present. Usually in an atom, the number of protons is equal to number of electrons. When the atom is stable, when the atom is neutral, you will find protons which are positive in charge, their numbers are equal to number of electrons which are negative in charge. The total number of protons is called as the atomic number. Atomic number is indicated by the letter Z. This is equal to the total number of protons present in a cell. That is the positively charged particles. This is positive and this is negative. They carry a negative charge and neutrons are neutral. Atomic number represented by the letter capital Z is equal to number of protons, and if this atom is neutral, that is number of positive charges is balanced by number of negative charges, then this is also equal to number of electrons. Now it is seen that the shell number 1, immediately after nucleus, this shell is called the shell number 1. It has a capacity to hold maximum of 2 electrons. So if you draw the electrons like this, you will find maximum 2 electrons can be present in the first shell. After that, if required, more than 2 electrons are there in a shell, then they will move on to the second shell. This is shell number 2. This shell number 2 can hold maximum of 8 electrons. So this we can represent in this way: 1, 2, 3, 4, 5, 6 and 7, 8. Every atom tends to satisfy its total number of electron holding capacity. That is, the first shell only can hold 2 electrons. From second shell onwards, all other shells that are required, they can hold maximum of 8 electrons. Due to the atomic number, if the number of electrons are less than 8 in any of the shell, they can do two things. Either they will accept electrons to make it 8, or if the electron number is less, they can give up the electrons so that they move back to the previous shell. Suppose in this atom, you will find it has 8 electrons. Suppose we think about an element with 11 electrons. So for this element with 11 electrons, first shell is holding 2, second shell is holding 8. So we are left with how many? To get 11, we are left with 1 electron. So the second shell has fulfilled its capacity of holding 8 electrons. So then it moves on to the third shell and that single electron will be present. This outermost shell of an atom is called as the valence shell. Not all shells, the outermost shell of an atom is called as the valence shell. And the number of electrons present on that outermost shell, they are called as the valence electrons. So here in this figure, how many valence electrons are there? 1. Now it will try to either accept 7 electrons so that it becomes 8, or it will try to give up that 1 electron so that the second shell remains satisfied. Third shell to be satisfied needs 7 more electrons. So there are 2 possibilities. Either it will take 7 electrons plus 7 electrons, or it can give up 1 electron. Which do you think is easier? Obviously giving up the single electron is easier than accepting 7. So what it tends to do, it gives up the electron. So in this shell, if 11 electrons were there, 11 protons were also there. So 11 protons were there and are there in the nucleus, but out of 11 electrons, 1 electron it is donating, so that it attains the stable number of 8 in the second shell. So as a result, 11 protons minus 10 electrons. Now 10 is left, 1 it has given up. So the cell will be having 11 minus 10 is 1 plus. So you will find this element has 1 positive charge more and 1 negative charge less. How we will come to this? You will find if I consider the valency of an element. Valency of an element is the combining capacity of the atoms of an element. This we can express in 2 ways. 1, valency is the combining capacity. So you will find we can also define it that the number of hydrogen atoms, valency is number of hydrogen atoms that can combine with or displace one atom of the element or radical forming a compound. Now, what is this radical? When a single atom or a group of atoms behaves as a single unit, one atom or a group of atoms behaves as a single unit and carries a charge on them, we call it as a radical. You'll find oxide radical we have from oxygen. We can have chloride radical from the element chlorine. Okay, and when it is a group of atoms, say we can have the carbonate radical, which is made up of 2 types of atoms, atoms of carbon and atoms of oxygen. So this is one definition. Examples, let's see, if you take 3 compounds, HCl, hydrogen chloride gas, we are taking water. This is hydrogen chloride. You need to learn the symbols and the valency of elements in order to write the formula of a compound. This is water. And we are taking ammonia. Remember, you had studied about the pungent smelling gas, that is ammonia. In the first compound, what do we see? That 1 atom of hydrogen is combining with 1 atom of chlorine. So, valency of chlorine is 1. Number of hydrogen atoms combining with one atom of the element. So number of hydrogen atom combining with chlorine is 1. Valency of chlorine is therefore 1. In case of water, 2 hydrogen atoms are combining with 1 atom of oxygen. So valency of oxygen is 2. 3 hydrogen atoms are combining with 1 atom of nitrogen. So valency of nitrogen is 3. So this is one way of defining valency. The second definition of valency states that it is the number of electrons that it accepts or gives up from the valence shell or outermost shell of an atom. Remember, we studied this: protons in the center, neutrons in the center, that is in the nucleus, surrounded by orbits which can be minimum 1, maximum according to number of electrons. So if we had done the example with an element having atomic number 11. So atomic number 11 means proton is 11, electron is also 11. So how do we arrange them? What did we see? This is the nucleus. So the first shell, this is shell 1, can have maximum of 2 electrons. Second shell can have maximum of 8 electrons. 4, 6 and 8. Still we are left with 2 plus 8, 10. Still we are left with 1 electron. For this we move on to the third shell. So this third shell is the valence shell and this is the valence electron. So either this electron can be given off or it can accept 7. Accordingly, the valency of the element will be decided. Now, for your information, you will find atomic number 11. Metal sodium has atomic number 11. That is 11 protons, 11 electrons it has. In order to become stable, instead of accepting 7 electrons in the outermost shell, it has 1. So either it can take 7 or it can give up this 1. It can donate this 1. So it is easier for this element to donate the 1. So from its 11 protons, this remains constant in the nucleus. But from 11 electrons, it is giving up 1 electron, donating 1 electron. So this becomes 10. So 11 minus 10, we are getting 1 extra positive charged particle. So valency of sodium is, symbol of sodium you know is Na. So we write it as 1 plus. Many a time you need not write 1. If you write plus also, it means 1 plus, or you can mention 1 plus. Now from this, we can learn to write the formula of a compound. For this, once again students, knowing the symbols of the elements and the valencies of the element is very important. You have to study the chart, understand it, learn it, but definitely without that, you cannot write the formula of a compound. Let's take a simple compound. We'll take sodium chloride. Now, do you know what we commonly call this compound sodium chloride? It is the common salt that we use to give taste to our food, the salt that we eat. That is common salt. What is the symbol of element sodium? Sodium has the symbol capital N and small a. This is derived from its Latin name, which is natrium. Chloride or chlorine. Chloride is a radical. Its symbol is capital C and small l, not capital L. Capital C and small l. Okay? It has valency of sodium, we have found out from the previous diagram, is 1 plus. Valency of sodium is 1 minus. In order to write the formula of a compound, when we write the formula of a compound, we need to interchange the valency of the element. Valency of sodium will come here, valency of chlorine will go here. So because both sides it is 1 each, there will be no change in the number of atoms and we say that the symbol of this compound, formula of this compound, sodium chloride, is NaCl. So what is the formula? It is the representation of the symbols which forms the compound. Symbols of the atoms of the element which forms the compound. This is called as the chemical formula. From the chemical formula, we get certain information. What are the different elements taking part in a compound or that are involved in a compound, and what else we are getting from this compound? How many elements are there? Element sodium and element chlorine. What else we know? The number of atoms of each element that is present, that also we know. So how many atoms? One atom of sodium and one atom of chlorine. If you take another compound, let's take calcium carbonate. Again, this is a compound which is known to you, the chalk, calcium carbonate. What is the symbol of element calcium? It is capital C and small a. Carbonate is the compound radical having the symbol CO3. Okay, so how do we write the formula of this compound? So first of all, we had to know their symbols. Second, we need to know their valency. Valency of calcium is 2+. Calcium being a metal, most of the metals have positive valency, it is 2+. Carbonate being a radical, it has valency 2-. So when you interchange the valency, 2 of calcium goes here and 2 of carbonate comes down here. So because it is 2, same on both sides, you will find we can cancel this by the common factor 2 and we will get 1. So number of calcium atoms will be 1, number of carbonate radical will be 1. So the formula becomes CaCO3. Because it is 1, we need not mention it separately. One more example, let's see. If you take sodium, we are taking, and carbonate we are taking. So if you take the compound sodium carbonate, we already know symbol of sodium is Na1+. Carbonate is CO3 2-. Be very careful, students, when you are writing the symbols. Capital N and small a. If you write capital A, even if your answer is correct, you do not get any marks for it. For carbonate, which is made up of atoms of 2 elements, carbon and oxygen, both the symbols of carbon and oxygen should be capital. And O should be written, the number should be written slightly below the line. This being a metal has positive valency 1. This being a radical has negative valency 2-. So what is the rule of writing the formula of a compound? We have to first write the valency, then interchange the valencies. Valencies are getting interchanged. We bring 1 of sodium here and 2 of carbonate comes here. So 2 goes with sodium now and 1 goes with carbonate. So now what is our formula of the compound? Na2, where do we write? From this lower part till down below. We do not write it along the line where we write sodium. And how many carbonate? Only 1. If 1 is there, you need not mention that number. So formula of sodium carbonate is Na2CO3. Make sure that not much gap is there between these two. Otherwise, these will appear to be a different compound. So sodium carbonate is Na2CO3. Do practice, first of all, learn the symbols of all elements, the valencies of the elements, and then only you will be able to write down the symbols correctly, put the right valencies and interchange the valencies to get the chemical formula of the compound. all these we are studying they are the chemical formulas. So chemical formulas are the representation of the compound along with their symbols, from which we know the number of elements present in a compound, the number of atoms of each element that are present in one molecule of the compound. Once again, we know the number of elements present and the number of atoms required to form one molecule of a compound. That is what the chemical formula denotes. To study the chart, children, which is very important to write, to remember these symbols, the valencies, in order to write the chemical formulas correctly. Because if you are able to write the chemical formulas, later it will be very easy for you to write the chemical equations. Thank you.